Electricity, gas lines, waterworks, sewage systems, and communication lines are part of the public utility system. Considered as essential services, they all play an important role in our everyday lives. Public safety, transport services, economy, and the environment can be dramatically affected by service interruptions to the public utilities network. Unfortunately, cables, pipes, or ducts are too frequently damaged by inadequate excavating procedures, all of which could have been avoided by the use of protective measures. While the cost of repairing underground structures is easily known, social costs, as well as indirect costs, are harder to quantify. Work delay, traffic congestion, mobilization of first responders, lawsuits. So before digging, perforating, or excavating the ground, please take the time to properly locate and protect underground infrastructures. It's not only your legal duty, the public safety also depends on it. Dial the Info Excavation Call Center, our one-call system, before initiating work. Explosions, fires, shutdown of emergency lines, electrical failures, water shortages, or heating shortages in winter are some of the major effects of inadequate excavation procedures. To avoid such disasters, every precaution should be taken when doing excavation work. The Alliance pour la protection des infrastructures souterraines du Québec, a non-profit organization, is dedicated to developing and improving known expertise as well as having the best practices in damage prevention to underground infrastructures. Its goal is to ensure a safe environment for the public and workers alike while maintaining the integrity of public utilities. Careful, safe, and non-invasive methods that gradually expose underground facilities are considered secure excavation practices. Certain guidelines for excavating near infrastructures allow the use of heavy equipment to strip surface material, such as pavement, except when it comes to removing base material around infrastructures. Soft excavation methods allow the removal of surrounding material in a safe and efficient manner. The following is a list of soft excavation methods and their guidelines that are available to all excavators. Soft excavation techniques are used when precision is required. They are deemed as safe as conventional excavating methods. They can be used in various applications: cleaning of reservoirs and conduits, backfill and opening of trenches, drilling and clearing of underground infrastructures. These techniques are proven to be effective when it comes to excavating areas with access issues and when the risk of damaging underground facilities is high. They also help reduce environmental impact and can diminish costs related to repairing infrastructures. With their high-precision methods, the excavation area is reduced, which in turn translates into a lesser impact on traffic and the surrounding areas. These techniques can also help reduce operating time. Contrary to conventional excavating machinery, these methods do not require a slow operating process when nearing an underground infrastructure. As with other types of excavation, worker and public safety are considered top priority. The contractor using a soft excavation method must employ trained and qualified personnel that know how to use the equipment for the work at hand. The use of non-specific equipment, as well as untrained or unqualified operators, can harm workers and citizens alike. It can also damage underground facilities and have a negative impact on the environment. The excavator must take all necessary precautions to prevent damage to underground facilities, as well as surrounding areas, when working inside a buffer zone. Even while using soft excavation methods, the excavator must communicate with the Info Excavation Call Center and the landowner in order to determine and locate underground infrastructures in the excavation site. Before starting any soft excavation work near underground facilities, the excavator must take the normal course of action by making a locate request. Companies using underground facilities have agreed upon a color code to better identify the type of underground network. Every member marks clearly the exact location of its underground network by using the color corresponding to the type of network. The excavator must verify that the soft excavation method used is within the rules and instructions pertaining to each owner or operator. There are 3 soft excavation methods: hydro excavation, pneumatic excavation, and manual excavation. Climate and site conditions must be assessed before deciding upon which soft excavation method should be used. Here is a detailed description for all 3 methods. Hydroexcavation is a non-destructive process which combines pressurized water and a vacuum source to remove the material surrounding the underground infrastructures. This process allows for quick, clean, and precise evacuations. Considered as mechanical excavation, it combines three systems: water, pressure, and vacuum into one mobile, self-contained unit. Pressurized water is injected through the soil using water guns. Its high accuracy allows for safe and precise excavation of material around the infrastructures. The soil and water slurry are conveyed through a vacuum tube and temporarily stored in a truck-mounted debris tank. The main benefit of hydroexcavation, rather than conventional excavation machinery, is its surgeon-like accuracy. This soft excavation method is proven to be one of the best practices when it comes to excavating in congested underground areas or in frozen ground. Whatever the type of soil or season, hydroexcavation eliminates almost all risks of damage to underground infrastructures in areas that are difficult to reach by conventional excavation methods. Pneumatic excavation is another type of soft excavation method which employs a vacuum system. Here, compressed air is used to excavate material surrounding the infrastructures. It penetrates and dislodges the soil, which is then pumped into a vacuum conduit. This method is perfect for non-cohesive or non-frozen soil. When working with sandy soils, the jet of compressed air may sometimes cause a sandblast effect and damage either sensitive infrastructures, soft protective coating surrounding cables, or other types of protective coating, such as paint or epoxy, that are found on ducts. Contrary to hydroexcavation, this type of excavation is inefficient when excavating in frozen ground. On the other hand, pneumatic excavation does not create water slurry. It leaves the material dry, therefore immediately suitable for backfill once the excavation is done. Manual excavation is the slowest of soft excavation methods, but is considered just as efficient and non-invasive as the other two methods. It is proven most efficient in excavating areas where soft ground, gravel, sand, and secondary backfills are present. The speed is such that a constant appraisal can be done while excavating. This method is inefficient when digging in frozen ground. All three proven methods offer precise and reliable access to underground facilities. They are considered safe and efficient excavation methods. The following chart shows the benefits and drawbacks for each method. Conventional excavation, efficient for hard surfaces. Speedy excavation for high-volume material. Limited precision, high risk of underground damage, high collateral impact. Hydroexcavation, operational year-round, high surgeon-like precision, limited environmental impact, quick, safe. Non-immediate reuse of backfill, limited use on heavy materials. Pneumatic excavation, high surgeon-like precision, limited environmental impact, quick, immediate use of backfill. Jet of compressed air through sandblast effect can cause damage. Inefficient when digging in cohesive or frozen ground. Limited use on heavy material. Manual excavation, precise, immediate use of backfill, flexible and versatile. Limited to soft ground, slow, limited depth. Leaks, holes, and cuts are some of the damages that can harm underground networks. It is mandatory to report any damages done to either the underground infrastructure or its protective coating. Once damaged, the risks of service interruptions or danger to the environment increase significantly. The owner-operator responsible for the damage must then inspect the infrastructure and assume all costs pertaining to its repair. The APISQ is instrumental in developing and promoting the best practices in damage prevention of underground infrastructures. The Alliance will continue to promote a sense of shared responsibility by all stakeholders in the prevention of damages to underground facilities. Awareness and educational programs are presently in the works in order to promote the use of the best practices by workers within the industry, as well as to inform the general public. All information can be found in the APISQ's Guide to Best Practices under Chapter 4. Damage prevention, a durable solution for all.